Good day, I'm Marjan Lester A. Duque, a representative of Team 3G, in which we're going to talk about the renewable energy and discuss about the ocean energy or what we call the tidal energy. So, what is a renewable energy? A renewable energy comes from a source that is not completed when used thus naturally replenish on a human time scale. So, energies generated from a natural resources. Generally, it indicates energies that are non-traditional and have a low environmental impact. So what are the examples of renewable energies? We have a solar, hydro, wind, and tidal, geothermal, and biomass. So these are the example of uh, renewable energies which is um, replenished on a natural way and di sila nauubos. Next, we have or we're going to discuss about the uh, ocean energy or the tidal energy. So we have the power station. So in descriptions, what is a tidal power or a tidal energy is harnessed by converting energy from tides, which is useful forms of power, mainly in electricity, using various methods. The working principle which the tidal energy is created using the movement of our tides and ocean where the intensity of the water from the rise and fall of tides is form of kinetic energy. Tidal power surrounds gravitational hydropower which uses the movement of water to push a turbine to generate electricity. So these are the causes of and frequency of tides. We have the high and low tides which is caused by the moon. So, the moon's gravitational pull generates something called the tidal force, in which this force causes Earth and its water to bulge out on the side closest to the moon and the side farthest from the moon, which these bulges of water are called high tides. So, most coastal areas, with some exceptions, experience two tides and two low tides every lunar day. However, a lunar day is 24 hours and 50 minutes. Because the Earth's rotates from two tidal bulges every lunar day, coastal areas experience two tides and two low tides every 24 and 50 minutes. High tides occur on 12 hours and 20 minutes apart. It takes 6 hours and 12 minutes for the water to store water at the shore to go from high to low or from low to high. So this is some question in which if high tides are caused by the gravitational pull of the moon on Earth, why there would be high tides on the side of the Earth opposite to the moon. So the answer is the high tide on the side of the Earth facing the moon is called high tide. Caused by the bulge on the opposite side of Earth is called the low tide. Or we have a low tide may be understood as the moon's tidal force pulling the planet, not the ocean, toward it. So this is a representation of the frequency of tides on Earth's tides. The side facing the moon which have the high tides which causes by the gravitational pull. And on the other side we have the low high tide. While on the upper and lower we have this low tide. So on the side facing the moon, gravitational attraction between the Earth and the moon is strongest on the side on the Earth that happens to be facing the moon, which is simply because it is closer. The attraction causes the water on this near side of the Earth to be pulled toward the moon. So the gravitational force acts to draw the water closer to the moon, and the inertia attempts to keep water in place. But the gravitational force exceeds it, and the water is pulled toward the moon, causing a bulge of water on the other side toward the moon, stated by Ross in 1995. Also, Ross stated that on the opposite of the Earth, or the far side, the gravitational attraction to the moon is less because it is farther away. Here, or in which talk about the far side, the inertia exceeds gravitational force, and the water tries to keep going in a straight line, moving away from the Earth. also forming a bulge. Then the gravity and inertia act in opposition on the Earth's ocean, creating tidal bulges on opposite sides of the planet. So the near side of the Earth, or the side facing the Moon, the gravitational force of the Moon pulls ocean water toward it, creating one bulge. On the far side of the Earth, inertia dominates, creating a second bulge. So this is also the representation of the tidal bulge caused due to inertia and gravity. And on this slide shows one of the largest tidal power stations. So we have five here. First, we have the Siwa Lake Tidal Power Station, which is from South Korea, that has the capacity of 254 milliwatts. Second, we have the Rance Tidal Power Station from France that has 240 megawatts, and Annapolis Royal Generating Station in Canada have 20 megawatts. Maygen is 6 megawatts, sorry, from the country of United Kingdom. So, lastly, we have the Jiangxia Tidal Power Station located in China that has 3.2 megawatts. On these slides, it shows the one of the largest tidal power station, which is the Siwa Lake Tidal Power Station from South Korea. So, yun. So, the next slide will be discussed by Miss Nagayo, which is the types of tidal power.
Types of tidal power. Una dito is yung tidal stream generator. Tapos yung next naman is yung tidal barrage. And syempre yung last yung tidal lagoon. So, a tidal stream generator are very similar to wind turbines except they are below the water surface instead of above or on land. The water's current pushes the blades of the turbine, which is connected to a generator that creates electricity. Yung tidal stream generator daw is gumagamit ng kinetic energy na gumagalaw na tubig upang paikutin yung isang turbine. Katulad sa paraan ng paggamit ng wind turbine na yung ginagamit is yung hangin para makalikha siya ng kuryente. Gayunpaman, ang power na magagamit para sa tidal power generation sa isang particular na lugar ay maaring mas malaki kaysa sa wind turbine dahil sa mas mataas na density ng isang tubig. Sa may tidal barrage naman, yung mga turbine niya is nasa loob ng barrage na gumagamit ng lakas ng tubig or sa parehong paraan na ginagamit ng isang river dam. Yung mga barrage gate, bukas sila habang tumataas yung tubig. Tapos kapag nagiging high tide siya, nagsasara yung barrage gate. Kasi lumilikha to ng pool or ng tidal lagoon. Tapos pagkatapos naman nun, yung tubig, inilalabas sa pamagitan ng mga turbine ng barrage na yon yung nagiging dahilan para makalikha ng enerhiya sa mabilis na pamaraan na maaaring kontrolin ng mga engineer. Tapos yung last natin is yung tidal lagoon. A new tidal energy design option is to construct circular retaining walls embedded with turbines that can capture the potential energy of tides. The created reservoirs are similar to those of tidal barrage except that the location is artificial and does not contain a pre-existing ecosystem. So dito sa may tidal lagoon, gumagana yung mga turbine niya habang pinupuno at nawawalan ng laman yung lagoon. So unlike tidal barrage, etong tidal lagoon pwede siyang itayo sa natural na baybayin.
Advantage of tidal energy. Tidal energy is a renewable source of energy, which means the energy doesn't deplete as it's use. Ang tidal energy ay isang renewable, hindi basta-basta nauubos, di katulad ng hangin o araw. Pag walang hangin, walang energy, at pag walang araw, walang energy. Zero carbon emissions. In addition to being a renewable energy source, tidal power station do not emit greenhouse gases during electricity generation. Predictable. Tidal currents are highly predictable. Low and high tides flow well-known cycle, making it easier to know why power will be produced substantially more energy than a wind turbine of the size. Ang current na inilalabas ay malalaman agad kung mataas ito o mababa dahil sa flow ng tubig. High power output. Tidal power plant are able to produce high amount of electricity. One of the main reason for that is because water is dense, almost 800 times more dense than air. This means that a tidal turbine will produce substantially more energy than a wind turbine of the same size. Ayon dito sa high power output, mas maganda ang tidal power plant dahil mas lamang ng 800 times dense ito sa hangin at kayang bumuo ng mas mataas na enerhiya. Disadvantage of tidal energy. Limited installation site. In order for tidal power plant to be built, the potential of installation sites must meet very specific requirements. First, they need to be located on a coastline which limits potential station sites to be coastal state. There are additional requirements. A potential site must meet, for example, tidal power station need to be built in place where the difference in height between high and low tide is significant enough to power turbines. This limits where the power station can be installed, making it difficult for tidal power to be implemented widely. Ayon sa limited installation site, marami pa ang kailangang ma-meet na requirements para makapagtayo ng isang tidal energy. At pangalawa, kailangan pa maghanap ng mga lugar sa tubig na may high and low tides para makapagtayo nito. At sa sobrang dami nga ng requirements ay iilan lamang ang pwedeng makapagtayo ng tidal energy station. Pangalawang disadvantage of tidal energy, expensive. One of the biggest drawbacks to tidal power is the high upfront cost. Tidal energy turbines need to be much than wind turbines because of the high density of water. Most tidal power plants that are currently operation are made of tidal barrage. The construction of tidal barrage is extremely expensive. The Ran's power plant was expensive to build its day and took about 20 years to actually pay for itself. This is one of the major reasons that proposed 7 barge has not gone ahead. Ang tidal energy ay sobrang magastos dahil aabutin ito ng matagal, aabot ito ng mga 20 years sa pagpapatayo pa lang nito. At ang huli sa disadvantage of tidal energy ay yung environmental effects. Tidal barrage disrupt the natural flow and water in and out of. This can have an effect of marine life, disrupting life cycle and spawning. Underwater turbine have the potential to kill marine life much like the wind turbine kill the birds. The concern valid among all tidal power plant, but larger marine life is likely to only be affected by tidal stream generators. Since the tidal barrage construction was complete, there were several impact to the local environment. However, 10 years later, it was considered the Rand's inquiry once again had a rich diversity of aquatic life. After the seawall was built in 1994, pollution built up the newly created Shiwa Lake Reservoir, making its water useless for agriculture. Constructions of perchloroctane sulfonate measured in the lake Chwa were among of the greatest ever measured in the environment.